Hi everyone, welcome back to Array series. Hope you're doing good. This is Mahesh. In this video, we will solve Leetcode problem number 27, which is remove element. Okay, let us try to understand the statement of this problem. So, given an integer array nums and an integer val, remove all occurrences of val in nums in place. The order of the elements may be changed. So this is a point to note. So you can change the order of the elements in the array and then return the number of elements in nums which are not equal to val. Okay. So consider the number of elements in nums which are not equal to val be k. So if you remove the val in the nums array, then whatever the remaining elements will be there, if you count them, that count will be equivalent to k. Okay. To get accepted, you need to do the following things. So change the array nums such that first k elements of the nums contain the elements which are not equal to val. Okay. The remaining elements of the nums are not important, as well as the size of nums you need to return. Okay. And also return what is the value of k here. Okay. So if you see the examples, they have given few examples. So in the first example, 3, 2, 2, 3, val 3. If you remove 3, 3, then we will be remaining with 2, 2. But you also need to keep the empty spaces, or you can keep anything. I mean, that really does not matter, as long as, you remove those elements from the initial k places. Okay, that initial k places will be equivalent to the non-val numbers, the number of non-val numbers. Okay, with that, maybe we can also look into the constraints. So nums dot length will be between 0 and 100, and nums of I will be between 0 and 50, and val will be between 0 and 100. Okay, with that, let us switch to editor and let us try to understand this problem. So now what they are expecting, so we have given this particular array and they have given this particular value. So which is val equal to 2 in this particular case. Now if you see, it contains 2, 2, 2 here. So basically 3 2's. Okay, and overall length of this particular array is 8, and the number of occurrences of 2 is 3. So if you remove 3 from 8, then 5 is our k value, which is equivalent to the length of array which we get after removing this particular value. But if that is the case, what we could have done, we could have simply counted non-2 numbers here. So basically this is 1, this is 2, this is not 3, 4, 5, and that's it. So we could have simply returned 5. But here what they say, they not only validate this k equal to 5, they also validate our array where the initial k values should be non-val, means it should not be 2. So it means it should be something like this. Then the remaining 3 places, you can keep them empty or you can keep them 2. That really does not matter, as long as initial k values will be the values which are not 2. Okay, so that is what they are expecting. And also one more thing what they say is, they really don't care what is the order of these numbers. So here 0 appears first, then 1, then 3, then 0, then 4. Correct, right? They really don't worry about this particular order. Even if you change this order, that is okay with them. So this is basically the problem statement, and we also saw the constraints. Okay, with that, maybe what you can do, you can pause for a second and then you can think for any possible solution, then you can come back to this video. Okay, with that, now before understanding the idea or the intuition, let us try to revisit our previous video. So what we learned in the previous video, move zeros towards end. So if you have not watched that video, I recommend please go back to that video and watch that carefully, and we will use the better or the best solution from that particular problem, and we will solve this problem. So what I'm trying to say, this problem is same as the previous problem, which is move zeros towards end. Okay. So in that problem, what we did, let us consider the same example: 0, 1, 2, 2, 3, 0, 4, 2. Okay. If this was the array, we moved 0 towards end, and remaining elements we moved them towards left. So if that is the case, my resultant array will be something like 1, 2, 2, 3, 4, then 2, then remaining zeros at the end. Okay. Now assume this value is not 2, assume this is 0 in this current problem. If that is the case, now you can correlate, right? Now we have the custom value given. So instead of 0, now what we need to do? We need to move this particular 2. So now if you try to correlate with moving 0 towards end, so this problem is same as the move zeros to end problem. Correct, right? So now assume we are trying, our value is given as 0. So it means I will simply skip zeros. I will simply skip zeros from here. Then at the end, it really does not matter, right? Whether we keep 0 or we keep empty places. So that really does not matter. So considering that factor, this problem is same as the move zeros towards end. Correct, right? So if that is the case, then we will reuse our better solution from the previous example. Even you can use the best solution. Both of them are valid here. But better solution, we will take that and we will tweak a little bit, and then we will try to come up with the solution for this particular problem. Okay. So now, what is that better solution we saw in the move zeros problem? So in that, what we did, so again I will take the particular array 0, 1, 2, 2, 3, 0, 4, 2. Okay. Now instead of 0, now I will directly deal with 2. Okay, because here we have given the value as 2. Now what I will do, I will check each number, and if it is 2, then I will try to move that towards end, and the remaining elements I will move them towards left. So now, is this number 2? No. Then I'll move to next. Is this number 2? No, that is not the case. Is this number 2? Yes, it is. Then next I will search for, or I will go to a number which is not 2. Now what I will do, I will simply put this pointer here for having reference to this particular 2. Now what I will do, I will check next number. Is this number 2? Yes, it is. Then I will skip and I will move. Now if you see, I have a different number. So if that is the case, I will simply move this number here. So this will become 3. Then this pointer I will move to the next available number. Okay. Next, this pointer will go to next number. Now again, this is not 2. So if that is the case, I will simply move this number here. So I will remove this. I'll put 0. Then I will move my red pointer here. Okay. So I will have to keep 0 back here. Now with that, our 0 again moves, this pointer moves towards right. Again, this is 4, correct, right? Now if that is the case, this is again not 2, then I will have to move this here. So I will remove this. I'll put 4 here. Then I will remove this pointer, and pointer now points here. Okay. Now after this, I will move this pointer here. Okay. Now if you see, my red pointer is here, right? Now again I got 2. So this pointer moves away and I'm done with my array. So if that is the case, now if you see where this pointer is pointing, if I add the indexes 2, 3, 4, 5, 6, 7. So if you see the red pointer where it is pointing to 5. So 5 is basically our k. K is equal to 5 for us here in this particular example. Correct, right? So after this modification, and also if you see the modified array, last two numbers we really doesn't care. I mean what those two numbers are. But we have all the non-2 numbers here in all these places. Correct, right? So that is what we wanted. So basically what I'm trying to say, we will simply reuse whatever the better solution was there from the move zeros problem, and we will tweak and we will come up with the solution for this particular problem. Let us look into that pseudocode now. I will just go back to our previous code. If you see here, this is our previous pseudocode. I will remove few things. This is not required. We are not placing 0 at the end. So, which we saw, right? I will simply return my index from here. This way, this index will give us value of k, and this modification will replace all the vals from the nums array. Okay, so let us switch. So to solve this problem, I'll simply go back to my previous submission to the previous problem, and I'll copy whatever the solution was there. So this is what was the submission we did for the last problem. So I will copy this. Mostly I'll copy only this inside content. Okay, now I will go back to my current problem. I will paste it. I will format it. So now we don't require this part because we are not going to add the value at the end, because that is not really necessary. And this one I need to change from 0 to val, because now we need to check the val, and at the end we need to return our index. This will give us the value of k. Now with that, let's try to run this. It got accepted. Now if you submit, our solution got submitted successfully. Okay, to editor. Okay, so now if you see this particular loop, it only iterates for one iteration. That's why our time complexity will be of order n, and we are not using anything extra, so our space complexity will be order of one space complexity. Okay, so this is one optimal solution, and we can also solve this in a one more optimal solution. So let us try to look into that. So when we were looking into the statement of the problem, what we saw, we heard, right? I mean, we saw, right? The order really does not matter when you remove the val from the nums of I array. So we will keep that in mind. And now let us try to come up with a different solution. Let me copy this array. Okay. So now what I will do, I will use a standard two-pointer technique again. So I will put a pointer at the beginning. I'll put a pointer at the end. So this is my left pointer. This is my right pointer. I'll better take a different color here. So this is my left pointer and this is my right pointer. With that, now you look for the number at the left pointer. Now it is 0. So which means it is not our val, right? Our val is 2. So it is not equal to 2. So I will simply skip this and I'll move. Why? because we have a non-val number here. So the number, whatever is there at this particular index, it is a correct number, correct, right? Now, the idea behind this is we are trying to find the right number at any place. So it can stay from 0 to k places, right? So I'm trying to find that. So 1 is not val. So if that is the case, I will simply skip this and I'll move to next number. Now if you see, we are getting 2. So it means we need to remove this 2, right? So if that is the case, now what I will do, I will take the number which is at my right position. I will take that and I will put it at this particular position and I will shrink it. Why shrinking? Because now if I remove one element from this particular array, its size will be decreased by 1, correct, right? So I will use that technique. So now what I will do, I will move this here. So since it is 2, there is nothing to copy. Move in the sense, basically I'm trying to copy this value from here to here. Okay. So since it is 2, anyhow, this is done. Now I will have to move this pointer towards left. That way I'm shrinking the size of the array. Now, if you see, I will remove this. Now again, I get 2 at this place. If that is the case, what we need to do? Again, we need to take the number from the end and we need to place it here. So now I have 4 here. I will simply put 4 and I will move this pointer towards left. So this is basically shrinking the array. It means I'm trying to remove the element and I'm trying to reduce the size of the array. Correct, right? So now I have 0 and here I have 4. So since it is 4, which is a not 2, then what I will have to do, I will have to simply move this pointer to next index. Now if you see, again I get 2 at this particular place. If that is the case, then what I need to do, I need to move this number to this place. That way I'm again removing one more number. So now I will copy that 0 here and I will move this pointer towards left, and also I don't need to move at this particular point only. So now again I will check my element at left pointer. Now it is 0. So it means this is not equal to 2. So it means this pointer should move to next number. Now if you see here, again this number is not 2. So again this pointer moves to next number. So now if you see, this is my left pointer and this is my right pointer. So whenever they cross, I will simply stop, because that is the point where this work is done. So if you see where this particular left is getting stopped, if you see the index 0, 1, 2, 3, 4, 5, 6, 7, if you see, it is stopping at 5th index. So what is the k that is required for us? K equal to 5. So we are getting that. So you can simply return k, and if you do this modification in line, so initial these numbers are not this particular 2. So we got whatever we wanted, right? So we did this in one iteration. So that's why the time complexity is of order n and space complexity is of order 1. So this way optimally we can solve this particular problem using this second optimal solution. So let us try to write the pseudocode for that. So now what I will do, I will take n equal to nums dot length, then left equal to 0 and right equal to n minus 1. Now what I will do, I will use a while loop, not a for loop, while my left is less than or equal to right. So basically our left pointer should cross the right pointer. That's when we stop it. Next, what I will do, I will check if nums of left, if it is equal to our val, then what we need to do, we need to bring the right side number and put it here. So nums of left equal to nums of right, and after this we need to decrement the right pointer, so right minus minus. Okay, if that is not the case, if it is not val, then we simply move our left pointer by 1. Okay, so now at the end you can simply return the left pointer. So this will make sure to modify your array, and this will make sure to return your k value. Okay, so with that we have already seen this will happen in O of n time complexity and O of 1 space complexity. Okay, let us try to execute this and see. Now I will remove this part and I will take it as left. Then I will take another int right pointer which is equal to n minus 1. Now I will use a while loop while left is less than or equal to right. Then it means until unless our left crosses right pointer, I will check if my nums of left, if this is equivalent to our value, then what I will do, I will simply remove that number. It means nums of left equal to nums of right. I will bring the number from the right and I will remove that. Then after that, I will have to shrink the size by doing right minus minus. So instead of doing here, I will simply do that here for better readability. Then if that is not the case, then we have right number at, the correct number at the left position. So it means we need to simply increment our left pointer. Okay, at the end, now what I will do, I will simply return my left pointer which is pointing at the value k. So with that, let's try to run this. Our solution got accepted. Now if I submit, our solution got submitted successfully. Now we discussed two optimal solutions, right? What is the difference between these two optimal solutions? So basically the first optimal solution, it will keep the order of numbers in the array, but the second optimal solution, it does not keep the order of numbers in the array. Why? Because we are randomly taking the number from the right and we are inserting it at any number wherever we get val. So that's why, that is what is the main difference between the previous optimal solution and this optimal solution. Okay, with that, I hope you liked the explanation. If that is the case, please consider subscribing to my channel and also like the video, share this with your friends. And also if you have any problems that you want me to solve, you can add that as a comment in the video. Thanks for watching the video.